I'd like to demonstrate some of the features of the SolidFire storage plugin for CloudStack. Right here I'm using a development version of CloudStack 4.9. We can see I have a single zone, single pod, single cluster with two hosts in it. Let's drill down there. We can see these are two 6.5 Zen server hosts. Moving back to the infrastructure tab, we can see two primary storages. Let's drill down into this area. These are both of the local storages of my two Zen server hosts. Now, I'd like to go ahead and add primary storage to CloudStack that's based on one of the two SolidFire storage plugins. To go ahead and do this, I'm going to click on the Add Primary Storage button in the upper right-hand corner. Now, here we see we have the ability to add primary storage either at the cluster or zone level. In this particular case, this primary storage is going to be zone-wide. So I'll go ahead and select that. For hypervisor, we're typically accustomed to primary storage being in a particular cluster and therefore being associated with a particular hypervisor type. In this case, this kind of zone-wide storage is actually associated with what we call here any hypervisor. So in reality, the SolidFire storage plugin supports KVM, VMware, and Zen Server. But we're going to go ahead and select any here. I only have a single zone, so we'll leave what's selected as the zone, and we'll provide a name. Let's provide the name maybe SolidFire SAN 1. Under Protocol, we're going to go and select what's called Custom. This is going to drop down a new provider field, and instead of leaving the default primary provider, which is the default plugin for storage in CloudStack, we'll go ahead and click on this combo box. We can see there's a few others that are installed by default. There's actually two SolidFire storage plugins. I've got one selected here, and here's the other one, SolidFire Shared. The SolidFire plugin is the one that we're going to focus on for this video. This is a plugin which allows you to have a dedicated backend volume per virtual disk. And with SolidFire, this allows you to guarantee quality of service on a virtual disk by virtual disk basis, therefore. So let's go ahead and pick SolidFire. We see some additional fields here. This particular SolidFire storage plugin is what's known as managed, so I'll go ahead and check the box, but in reality this particular plugin will act as managed storage whether or not you check this box. Now here in the capacity bytes section, we want to tell CloudStack how many bytes from the SolidFire cluster we're allowing CloudStack to make use of when it creates volumes. So let me go over, I have this in a text document. Since this is actually a fairly large number here, it's 2 petabytes is what I'm going to be giving to CloudStack. I'll go ahead and copy this and paste it in here. So what this is saying is I'm allowing CloudStack to use up to 2 petabytes of my SolidFire clusters when it makes volumes in CloudStack that are on primary storage that's backed by the SolidFire storage plugin. Now, in addition to capacity bytes, we also want to specify capacity IOPS. Now, this is the number of IOPS that we can draw from the SolidFire cluster to support our volumes in CloudStack. So in this case, I'm going to go ahead and give CloudStack access to 4.5 million IOPS. So what this is saying in aggregate is that CloudStack using this primary storage, can make volumes until it exceeds either the capacity bytes and or the capacity IOPS of the SolidFire cluster. Now the URL field, this is really a collection of key value pairs that are of interest to the storage plugin so that it can communicate with its backend system. So for example, the IP addresses, the username, the password, information like that. And it's in a key value pair format, semicolon delimited between key value pairs. I'm just going to go ahead back in my text document, copy this information, and then paste it into the URL field. Now for storage tagging, this is just like any other primary storage in CloudStack. I'm going to create a storage tag. In this case, I'm going to make it something unique. It's, in this case, only going to be used by this particular primary storage. So I'll give it a name like SolidFire SAN A. Now that we have all of our information in place, I'll go ahead and click on the OK button, and we'll see that our primary storage is created in a moment. Here we are. We have its name. This is what's called the storage virtual IP address in SolidFire terminology. This path is a combination of both what SolidFire calls a management virtual IP address and a storage virtual IP address. We provided that information and other information when we gave that URL field. Now we're not cluster-wide storage, so this field is empty. The scope is zone. Now let's go ahead and drill down into this particular primary storage just by clicking the name field in the table. Here we are. We see the name of the primary storage, its unique identifier. We see that the state is up. It has a storage tag. It's in zone 1. It is not specifically associated with a pod or a cluster because this is zone-wide primary storage. Its type is iSCSI. The IP address, as I had pointed out earlier, this is actually what we call the storage virtual IP address, and we can see it as well down here in the path along with the management virtual IP address. So the management virtual IP address is where we send commands to the SolidFire system like create an account, create a volume. The storage virtual IP address is typically used on the storage network from the hypervisor host to read and write volumes in the SolidFire cluster. The capacity of our system that we've given to CloudStack for this primary storage is 2 petabytes. We haven't allocated anything yet, and we have 4.5 million IOPS that we can allocate as well. Now that we have primary storage in CloudStack that's making use of the SolidFire storage plugin, let's go ahead and create service offerings to make use of this particular primary storage. I'll switch over to the Service Offerings tab, and by default we're on the Compute Offerings section. In the upper right, I'll click on Add Compute Offering and provide a name, something maybe like SFCO1 for SolidFire Compute Offering 1. And then in the description, let me make something similar like SolidFire Compute Offering 1, and I'm going to provide a hint here as to what kind of performance we're providing. It is going to be 100 minimum IOPS and let's say 300 maximum IOPS. Now I say it's a hint because I'm not really going into a whole lot of detail as to what I/O size we're referring to and things like that. We're really referring here to 4K I/O, and you can scale that appropriately for your particular I/O. So if it's on average you're doing maybe 8K I/O, you're going to be getting fewer than 100 IOPS in that particular case. So what I'm doing here is mainly for demonstration purposes, just to give us an idea what to expect for this particular compute offering. in your particular environment, you might be very detailed about what kind of performance is going to be offered by a particular compute offering or disk offering, or you may be a little more vague, maybe fast, medium, slow. So in this case, what I'm saying here is 100 4K IOPS is the minimum, 300 is the maximum. So we'll keep storage type shared. We can ignore the provisioning type. SolidFire is always thinly provisioned, both from a metadata and data standpoint. From the CPU cores, let's just stick in the value 1, maybe 200 megahertz for the CPU, and let's just do 128 megs of RAM. Now as I scroll down, we'll see a field called QoS type, quality of service type. By default, this is empty. I'll go ahead and select this combo box. Hypervisor QoS is rate limiting for the KVM hypervisor. What we're really interested in here is storage quality of service. So I'll go ahead and select this. This will lead to a few extra fields being displayed in this dialog. So let's select this. Now we can see here we have some new fields: custom IOPS, min IOPS, max IOPS, and hypervisor snapshot reserve. So custom IOPS, if I select this, it will remove the min IOPS and the max IOPS fields. So I'll select that just to demonstrate. What would happen here is when someone is actually going to spin up a VM that makes use of this particular compute offering, they would be asked for the minimum and the maximum IOPS. If they leave those blank, we'll actually provide defaults that we gave to the SolidFire storage plugin when we created primary storage that made use of that particular plugin. Now the more common approach here is to leave this unchecked and then provide the values, have the administrator provide the values. So in this case, we'll just do what I mentioned in the description. We'll take 100 for the value of min IOPS and 300 for the value of max IOPS. Now the hypervisor snapshot reserve field, I'll put in the value 200. This comes into play when you are making use of hypervisor snapshots. So from a Zen server standpoint, we want to create a single virtual disk within a single storage repository. No other virtual disks, for the most part, will be placed in that storage repository except for the one virtual disk. And that's how we're able to say, well, that virtual disk is the only virtual disk on that storage repository, and that storage repository is on our SolidFire volume with guaranteed quality of service. Therefore, we have guaranteed quality of service to the virtual disk. Now there's going to be some I/O going to the storage repository, but for the most part, all of that I/O is going to the virtual disk. When you take hypervisor snapshots, it actually creates a delta virtual disk image within the SR. So you would see multiple virtual disk images in that case within the same storage repository. However, those virtual disk images are all part of the same virtual disk from the point of view of your VM that's using the device that's backed by those virtual disk images. And so only in that scenario where you take hypervisor snapshots would you actually see multiple virtual disk images within the same storage repository. So what this hypervisor snapshot reserve field allows you to do is to create a backend volume, a SolidFire volume, that's actually a certain percentage larger than the virtual disk image within the storage repository. So as an example, let's say we have a virtual disk that's going to be 20 gigabytes. Now we don't really want our backend SolidFire volume to be exactly 20 gigabytes because there is some overhead for the storage repository itself, the metadata that it contains. And if you do take hypervisor snapshots, there's additional space that needs to be available within the storage repository for those Delta virtual disk images. So if you do have a 20 gigabyte virtual disk, what this is saying here, for example, at 200 hypervisor snapshot reserve, that's saying we want the SolidFire volume to be 20 gigabytes plus an additional 200% of that 20 gigabytes. So we've got the original 20 gigabytes plus 200% of 20 gigabytes, so another 40 gigabytes. So 20 plus 40, we got 60 gigabytes is what we'd expect the back-end SolidFire volume to be. And initially, you'll just have a storage repository with a single virtual disk image in it. That's 20 gigabytes. If you do then take hypervisor snapshots, you'd have additional virtual disk images within that storage repository that are taking up extra space. So now the final piece we need to fill in here is the storage tags. I'll go ahead and type in S, since I know the primary storage that I want to use has a storage tag that starts with the letter S, and I'll go ahead and select that one. So now we've got everything filled in. I'll scroll down to the bottom and hit the OK button. We can see in a moment our compute offering has been added. If we go ahead and drill down into it by clicking on the name field, we can see it has a name, an ID, the description, storage type is shared, and then the other relevant fields for us, number of CPU cores, CPU megahertz rating, and the memory. Let's go down a little bit lower to see the storage information. We are not allowing the end user to specify the IOPS, so custom IOPS is no. The min IOPS are 100, the max is 300, which is what we specified. Our hypervisor snapshot reserve is 200, as we specified. And the rest of this information is not particularly relevant other than the storage tag, which is SolidFire SAN A. The only primary storage we have, right now at least, that uses this storage tag is the primary storage we created earlier, that is using the SolidFire storage plugin. Okay, now that we have a compute offering, let's go ahead and make a disk offering. I'll go click on the Service Offerings tab again, and I'll switch over to the Disk Offerings section. In the upper right, I'll click on Add Disk Offering. And here, similarly, I'll make a name, maybe SolidFire Disk Offering 1, and a description that's sort of similar, but I'll provide information about the IOPS. Let's say minimum is 1,000 and maximum is 3,000. So this is different from our compute offering in that we have 1,000 minimum and 3,000 maximum IOPS as opposed to 100 and 300 respectively. Storage type is shared. Again, we don't really care about the provisioning type because all SolidFire volumes, both from a metadata and data standpoint, are thinly provisioned. Let's provide a size, 100 gigabytes. So when we execute this kind of a disk offering, our virtual disk will be 100 gigabytes. Now just to kind of point out, if you did check the box here, that size in gigabytes would go away, and the end user would be able to fill in how large they would like the volume to be. And that's a very similar concept to what we took for the IOPS, the custom IOPS checkbox. But in this case, I'm going to leave this unchecked, and I have 100 gigabytes specified. For the QoS type, again, by default, it's empty. If I click the checkbox, we can see the hypervisor option and the storage option. I'll go ahead and click on storage, and we'll see a couple extra fields again, the same fields that we saw in the compute offering appear. And here we are again. We have access to our minimum IOPS. Let's stick in 1,000. And our maximum IOPS, let's do 3,000. So that's consistent with our description. The hypervisor snapshot reserve, same concept as what we had for the compute offering, and I'm just going to put in 200 again. So just to show this From a custom IOPS standpoint, we can also check the box as you'd expect, just like with custom disk size, and provide the user with those options. In this particular case, though, I'll leave those unchecked, and myself as an administrator, I've specified those values. From a storage tag point of view, I'm going to place the letter S in here, and we can see we have one storage tag that meets that description. That's the one I want. I'll go ahead and click on that, and now we're all set. We've got our name, description, the size, the performance characteristics, our hypervisor snapshot reserve, and we've got our storage tags. So let's go ahead and click the OK button and create this particular disk offering. There we are. Our disk offering has been added to the database. Now that we've got a compute offering and a disk offering, let's go ahead and create a virtual machine that makes use of our compute offering. And after that's done, we'll go ahead and create a volume that makes use of our disk offering and then attach that to our virtual machine. Over in the Instances tab, in the upper right, I'll click on Add Instance. I want to do this from a template. In this case, I only have a single template, and it's already selected. I'll just click the Next button. I just have a single compute offering, the one that we made a moment ago, so I'll leave that selected and move forward. Now here I could create a data disk up front while we're in the process of making our virtual machine, but I'd like to actually, from a demonstration standpoint, do that in a separate step. So I'm just going to leave No Thanks selected and click on the Next button. I don't have any affinity requirements. Networking is okay. Not worrying about SSH key pairs here. And from a review standpoint, we can see our information looks good. I'll go ahead and just provide some simple name here, VM-1. And then I'll click on the Launch VM button. Now, what's happening here is when CloudStack needs to figure out where to put the root disk for this particular virtual machine, it's going to look for primary storage that can support it. Our compute offering specified a storage tag of SolidFire SAN A, and we only have a single primary storage, at least right now, that has the storage tag SolidFire SAN A. So it'll be a pretty easy decision for CloudStack to pick that particular primary storage. It has plenty of capacity, it has plenty of performance, so those are fine. It will go ahead and start executing methods on the underlying plugin that supports that primary storage. That's our SolidFire Storage plugin. That SolidFire Storage plugin will send commands to the backend SolidFire cluster to, if necessary, create an account for the volume, then create a volume, put the volume in the appropriate access control list, what we call a volume access group. That will allow the two Zen server hosts that I have to be able to access that SolidFire volume. And once that process is done, CloudStack will then tell Zen server to go ahead, attach to that particular iSCSI volume, create an SR on it, create a virtual disk within the SR of the appropriate size, and then attach that to the virtual machine that we're creating. So let's check on the progress here. I'm going to go over to the SolidFire GUI. I'll click on that tab. So we can see here I'm in the Accounts tab. SolidFire is a multi-tenant system. It has the concept of accounts. Your volumes go within accounts, and you can isolate volumes from each other that way by placing them in different accounts. Very similar actually to how CloudStack has accounts, and the accounts are what own the resources. In fact, we've taken that concept and mapped it directly into SolidFire so that in this case I'm spinning up a virtual machine. I'm logged in as some user that's in some CloudStack account. If that CloudStack account does not have a corresponding SolidFire account, when the time comes to make a volume for it, we will automatically make a SolidFire account and then create the volume in that account. So we can see here, I've actually run this in the past a few times. I already have 2 accounts. I have one, I'll go ahead and highlight it. This one is actually a SolidFire account that maps to the CloudStack system account. And the one below it, I'll highlight that one now, that is a SolidFire account that maps to an administrative account within CloudStack. Now if I click on the refresh button here, we'll see the current status of this information. We can see the system account has an active volume. Now let's go over to the Volumes tab and take a look at that volume in more detail. So we can see here it has a volume ID, it has a name, and it shows the account that the volume belongs to. This particular volume is not in a volume access group at the time being. We can see its size. If I go over to quality of service, we can see its minimum and maximum IOPS as well as its burst IOPS. And we can see other information about the volume. In this particular case, this SolidFire volume is associated with a CloudStack template, that Zen Server template, CentOS 5.6 64-bit. What we did was we created a SolidFire volume using the CloudStack system account. I really should maybe be a little bit more specific there. We had the CloudStack system account asking the SolidFire plugin to create a volume on its backend system. The SolidFire plugin would have created an appropriate SolidFire account for that CloudStack account if it didn't already exist. Once that was done, the SolidFire plugin made a new volume, and once that was available for use, CloudStack orchestrated Zen Server to go ahead and download the appropriate template from secondary storage onto that iSCSI volume. So first an SR was created, and then the VHD file on secondary storage was copied down to the new SR on our SolidFire volume. Once that was done, CloudStack was able to have the Zen Server hosts detach themselves from that particular volume. Then CloudStack talked to the SolidFire plugin about removing access so those Zen Server hosts no longer had access to this SolidFire volume that was created. What is actually happening here is we now have a SolidFire volume that has an SR and a VDI on it. The VDI is our VHD file from secondary storage. So going forward, and in the process here of creating a virtual machine that needs that template, what we'll do is we'll clone the SolidFire volume, and then we'll have a second SolidFire volume, but it will belong to whatever account was actually spinning up the virtual machine. So now let's go ahead and take a look at this again. I'll refresh this window. Okay, so we can see here, and I'll switch over to the Volume Overview tab. We can see that we have an initial SolidFire volume. It's in the account that maps to CloudStack's system account. It's not actually in a volume access group anymore. It was temporarily while we copied the data from secondary storage down to this volume. And then once it was there, the Zen Server hosts detached themselves from this SolidFire volume, and then the SolidFire plugin removed them from having access to this volume. So this volume effectively serves as a template on primary storage when we want to spin up VMs that need this template. In this case, now we are in the process of spinning up a VM that needs this template. And what we did at first then was tell the SolidFire system to clone this particular template volume. I'll go ahead and highlight it. Clone that highlighted volume to make the volume that I'm highlighting now, and it's placing it in the account that actually was responsible for kicking off the process of creating a VM in the first place. So this SolidFire account maps to the CloudStack account that was where the CloudStack user who kicked off the VM is part of. So now that we have a second SolidFire volume, we actually have to tell Zen Server, because this second SolidFire volume is an identical copy of the first. And Zen Server, using LVM, it has unique identifiers both in the SR and the VDI that need to be re-signatured, re-signed. And to do that, we actually have software on the Zen Server hosts that CloudStack in version 4.9 is able to make use of and take the SR UUID on our new SolidFire volume and create a brand new one, and then do the same thing for the VDI. So now our source volume, which was our template, and the volume that we created from it, they're identical in every way except for these unique identifiers are different. And so that makes Zen Server happy. Zen Server, if we make additional VMs that make use of this particular template, we'll go ahead and clone that backend template to make a third volume. We'll then go ahead and re-signature the unique identifiers of the SR and the VDI, so they'll be different from our second volume, which is different from our first volume, and so on. So everyone will have the same content with the exception that the unique identifiers are different. And so then Zen Server is able to actually have all of those iSCSI volumes which contain SRs in the same cluster because they all contain different unique identifiers. So once this process has been completed, we can go ahead and take a look from the Zen Server point of view, and I'll switch over to my Windows environment, and we can see here, I'll highlight it here, we have our new virtual machine. If I look at its storage tab, we can see it was a 20 gig template. So if we highlight this row, we can see that the size is 20 gigabytes, and that virtual disk resides on this particular SR. There's really only one shared SR right now, so it's pretty easy to locate. It's right here. I'm clicking on it. And we can see here it's a 60 gigabyte volume that's backing this particular SR and VDI. And that makes sense because the virtual disk from CloudStack's point of view is 20 gigabytes. And we said we wanted a 200% hypervisor snapshot reserve. So that should be an extra 40 gigabytes. So we should expect to see 60 gigabytes for the size of the SR, and we do. If we look at the storage tab here, we see that there's only a single virtual disk within this SR, and it is in fact 20 gigabytes. And this virtual disk is attached to VM I248 VM. So it's attached to the correct VM as well. So if we click on our virtual machine, we go over to its console view, and we'll log in here. And I'll do a clear and an fdisk-L, and I'll hit enter. We can see we have a single device. It's 20 gigabytes. And since this device is on its own SolidFire volume, it has guaranteed quality of service. In this case, it's in the amount of 100 minimum IOPS and 300 maximum IOPS. So we'll go ahead in a moment and we'll create a data disk from our disk offering. We'll attach that to this virtual machine. We'll see that there's now two devices, and we'll know that each of those devices actually has its own guaranteed quality of service. And in fact, those values are different. For the root disk, it's 100 min IOPS. For our data disk, it'll be 1,000 min IOPS. Now let's quickly go back over to CloudStack here and see. Here we can see we have our virtual machine up and running. If we click on the Instances tab again, the IP address will fill in. So that all looks very good. And if we go over to our notifications, We can see everything we've done to date has been executed successfully, adding primary storage, adding a compute offering that makes use of it, adding a disk offering that makes use of it, and spinning up a VM whose root disk makes use of our primary storage. So everything looks great. Now we'll go ahead and create a data disk using our disk offering. To do that, I'll switch over to the Storage tab. In the upper right, I'll click on Add. I'll provide some simple name, maybe just vol-1. I only have one zone, and I only have one disk offering right now, so those all are filled in appropriately. So all I have to do is hit the OK button, which I'll do now. In a moment, we'll see this volume has been added to the CloudStack database. It's actually in the volumes table in the cloud database. It's not actually associated with any primary storage right now. That will first happen when we attach it to a virtual machine, when we attach it to a virtual machine for the first time. So let's go over to the Quick View column and say Attach Disk. I only have a single virtual machine, so that one's selected by default, and I'll hit the OK button. Right now it's very similar to when we spun up our virtual machine in the sense that CloudStack is going to be looking for primary storage that can house the virtual disk of our, in this case, our data disk. It's going to see that our disk offering requires a storage tag of SolidFire SAN A. It will only find that requirement met by the primary storage that we created that's based on the SolidFire storage plugin, since that's the only primary storage that's specified a storage tag of SolidFire SAN A. Once it has that information, it can go and talk to the underlying plugin, which in this case is our SolidFire storage plugin, which will go off and create a brand new volume. And once that process has been done, CloudStack can tell Zen Server to go and create a brand new SR on that SolidFire volume, on that iSCSI volume, and then within it to create a virtual disk of the appropriate size. So let's go over to the SolidFire system and see where we're at. I'm on the Active Volumes tab. I'll go ahead and click the refresh button here. So we can see that we do have a new volume called vol-1. It is in the same SolidFire account as our root disk, which makes sense. And they're both in the same volume access group. So again, this is an access control list. It says which hosts can access which volumes. And both of our Zen Server hosts are in this volume access group, and both of our root disk and our data disk are in this volume access group as well. So that all is correct from a connectivity standpoint. We can see here we have a 300 gigabyte data disk. The reason, again, it's 300 is because our virtual disk was 100 gigabytes and it had a 200% hypervisor snapshot reserve. So that would be 100 gigabytes plus 200% of 100 gigabytes, so 200 gigabytes, equaling 300 gigabytes. If we look at the Quality of Service tab, we can see we have 100 and 300 for our root disk, which matches the compute offerings requirements. And we have 1,000 and 3,000 for our data disk, which matches our disk offerings requirements. And I didn't point this out, but the template takes up a minimum of 100 IOPS, and then it's very high actually for the maximum and the burst. So this is actually only really going to be used when we're copying the data from secondary storage down to primary storage. And we're saying we're going to need at least 100 minimum IOPS, but if the system has the available resources, we'll let you go all the way up to 20,000 4K IOPS to quickly copy that volume down from secondary storage to primary storage. And then once we have it on our SolidFire volume and we remove the hosts from accessing it, that volume is really only used from a cloning standpoint when we need VMs spun up that need to make use of that SolidFire volume that's acting as a template. So These are basically values that we didn't specify in any compute offering or disk offering. I'm referring here to the 100, 20,000, and 30,000 values. Those are values determined by the SolidFire plugin, and they're basically trying to say, I'll take up very few resources when you copy down from secondary storage to primary storage if we don't have many resources. We're only going to take 104K IOPS in that case. However, if you do have the resources, this process is happy to take those IOPS up and make that copy from secondary storage to primary storage very fast. And then once it's done and we detach the hosts from this particular template, they don't really need to perform front-end I/O anymore. So it doesn't really matter at that point much what these particular numbers are, because we're only going to be doing back-end cloning at that point on an as-needed basis. But the numbers that are specified by either an administrator or the end user, if the administrator sets it up that way, are the 100 and 300 values here for our root disk, which came from our compute offering, and the 1,000 and 3,000 here from our disk offering. And those, again, are either specified by the administrator, or if the administrator selects the custom IOPS option, then the end user can provide those values. The burst IOPS are actually determined by the SolidFire storage plugin based on the value in max IOPS. In this case, the primary storage, and we didn't really look at this, but one of the URL fields was how to calculate the burst IOPS. And we specified the value 1.5. So what is happening here is burst IOPS is set by taking max IOPS times 1.5. So here we have 450, which is just 300 times 1.5. Same concept here. We have 3,000 times 1.5, and that's how we arrived at 4,500. So we can see here everything looks great from a quality of service standpoint. If I go back to volume overview, everything looks great from a capacity standpoint. Go over to the volume details. We can see helpful information like the actual virtual disk for our root disk is 20 gigabytes. And if you were to go to the volumes table, it's ID 87. Same concept here. Our data disk is 100 gigabytes from a virtual disk standpoint, and it is ID 88 in the volumes table. So all of this looks great. Now we can go back to the CloudStack GUI, and we can see that we were successful at attaching our volume to our virtual machine. We can see over here the VM is VM-1 for this particular data disk. If we go over to Zen Center again, we can see that not only do we have our storage repository that's based on our SolidFire volume that's housing our root disk, we have a new shared storage repository, and this is based on a new SolidFire volume, and that SolidFire volume has an SR and a VDI within it. That VDI is our data disk. So if we look at the storage tab, we should see 100 gigabytes for our virtual disk, and we do in fact see that it's attached to the appropriate virtual machine. If we were to go over to our virtual machine, we can see here, well actually let me first go over to the storage tab. We can see that not only do we have a root disk, but we now have a data disk, which I'll highlight, and they're actually on two separate storage repositories. In this case, meaning they're on two separate iSCSI volumes on the SolidFire system. The one from a virtual disk standpoint is 20 gigabytes, and the other one is 100 gigabytes. But remember, that's the virtual disks within those storage repositories. So if we go back to our new shared storage repository and go over to its General tab, we can see that the actual size of the storage repository is 300 gigabytes, which does in fact match what we have on the SolidFire system, I'll go ahead and click on Volume Overview. We can see here 300 gigabytes. Now I know the one says 300 and the other says 322.1. The difference is one system is reckoning the capacity in terms of base 2 and the other is doing it in terms of base 10, but they are in fact the same capacity. So if I come back over to Zen Center again and click on the virtual machine, going over to its console, we can see our old information just when we had a single device for storage. I'll go ahead and clear this out and run fdisk-L again, and we should see two devices, one at 20 gigabytes, that's our root disk, and the other at 100 gigabytes, and that's our data disk. And there we are. The top one is 20 gigabytes. It is backed by a SolidFire volume guaranteeing 100 4K IOPS. The bottom one is 100 gigabytes, backed by a SolidFire volume guaranteeing 1,000 minimum IOPS. So not only, as you'd expect, do they have different sizes, but they also have different performance guarantees. So that's very, very cool from a quality of service standpoint. Let's say you have an application that doesn't really, once the operating system is booted up, a lot of the components are already in memory, and you don't really need to have a particularly performant quote-unquote disk for that root disk. You can have the quality of service be lower for that root disk, and then it might have multiple data disks, and perhaps they are being constantly bombarded by I/O, and they need to have higher performance. So you can do that on a very granular level with SolidFire and its integration into CloudStack. Okay, now let's take a look at a couple of the bigger features in addition to guaranteeing quality of service on a virtual disk by virtual disk basis. Let's switch back over to CloudStack and let's take a hypervisor, I guess let's call it a VM snapshot. It's a hypervisor snapshot of the virtual disks, and CloudStack refers to this, generally speaking, as a VM snapshot. So I'll go to the Quick View column, and I'll say Take VM Snapshot. You can provide a name or not. In this case, I won't bother to provide a name. Let's hit the OK button, and then switch over to Zen Center. And we can see here the VM is being paused, and it's going to, in a moment, be unpaused. And we'll take a look at the two SRs of interest to us. So this is our SR containing our root disk. This is our SR containing our data disk. And as we can see in both of these, now this is the data disk, this is the root disk. Instead of just having a single virtual disk within the SR, we now have multiple virtual disks within the SR. And these are the deltaing schemes that the hypervisor employs to keep track of the snapshot state versus the current state of the particular virtual disks. So this is a pretty standard feature that CloudStack provides, and I just wanted to demonstrate that with this kind of primary storage, this works just fine. If we want to in CloudStack, we can go back here and click on the VM, take a look at its snapshots, and we can see here that we have our snapshot. We can drill down into it. We can do the normal activities like reverting or deleting the snapshot, and expect the normal kinds of behaviors. For example, if I delete the VM snapshot, and I'll click on the Yes button, we should expect to see, if I switch over to Zen Center, we go back to kind of that normal state. We just have a single virtual disk now within our storage repository. This is our root disk SR, and here's our data disk SR, and we're back from where we started. So that's a really handy feature to have. And in addition to this kind of ability, you can actually take snapshots, volume snapshots, CloudStack refers to them as, which reside on the SolidFire system as opposed to having to be copied to secondary storage. So let's go ahead and take a look at what this all entails. I'll switch over to the CloudStack GUI again and click on the Instances tab. I'll click on my virtual machine, viewing the volumes. So here I've got, as you'd expect, my root disk and my data disk. Let's go ahead and create a volume snapshot of the root disk. So here I'll say take a snapshot, and I'll give it a name, say SS-1, and I'll click the OK button. Now, traditionally in CloudStack, what would happen is, I'll switch over to Zen Center, you would actually see a hypervisor snapshot taken, and then it would take one of the VDIs that is immutable, and it would copy that to secondary storage. So that process can take a while. What's going on here is we are actually taking a snapshot on the SolidFire system, which is very quick. So if we switch back over to CloudStack, we can see here, if we look at the notifications, scrolling down to the bottom, our snapshot has already completed. If I hit the close button and I dive into my root volume by clicking the name, and I take a look at its snapshots, we can see we have our snapshot. If I click on that snapshot name, we can see all of the normal kind of details that we're familiar with from normal kinds of volume snapshots in CloudStack. The only difference here is, instead of this particular volume snapshot being copied to secondary storage, it's stored on primary storage, which makes it very fast and very space efficient. So that's very neat. We can then take this particular kind of a snapshot and perform the normal operations that you'd expect. We can either create a template from it if it makes sense to do that, which in this case, this is a snapshot of our root disk, so making a template of that would in fact be a perfectly legitimate operation. We can also make a data disk from it. And in this case, let's go ahead and make a data disk from this. I'll click on the Create Volume, and then I'll provide a name, maybe vol-2, and then I'll hit the OK button. So what's going on here is we're taking our SolidFire snapshot, and let me actually switch over to the SolidFire GUI, and we can see here if I refresh it, we do in fact have a single snapshot on the SolidFire volume that contains our VM's root disk. So what's happening here, now that we've said to make a new CloudStack volume, we're actually taking this snapshot. I'll go ahead and click on it. It'll switch us over to the Snapshots tab. This particular snapshot is being cloned into a new SolidFire volume. Once that has been completed, now remember, we have a unique identifier on the SR and a unique identifier on the virtual disk image within the SR. So what will happen there is CloudStack, once it has access to this new SolidFire volume, will instruct Zen Server to provide new unique identifiers for the SR and the VDI. At that point, we're done. It was a very fast process, cloning the snapshot into a new SolidFire volume, updating the unique identifiers with Zen Server's help, and then we're done. So let's go ahead and take a look at the Volumes tab here and see what our progress is. Okay, we can see that we do have a new volume called vol-2, and it's of the appropriate size. I would expect, I'm going to highlight it here, I would expect these, actually this particular size, if I click on the snapshots, I would expect it to match this value here, and it does. Now, if we go ahead and take a look from CloudStack's point of view, it's still in the process of performing some work. And my guess is this is going to be the re-signing process on the Zen Server side. So let's switch over to Zen Center and take a look. Okay, we can see the storage repository vol-2. It's kind of appearing disappearing as we're probing it, we're collecting information about it, and then eventually it's going to go through the process of re-signing those unique identifiers. And that's actually happening right here. I recognize that icon. Now that this has gone away, I would expect if we switch over to CloudStack, in just a moment, this particular process should be done, and we should have a new CloudStack volume that's backed by a new SolidFire volume. And here we are, the process completed successfully. So if I go over to the Storage tab, we can see that we do in fact have a new volume. It's not attached to any virtual machine right now, which makes sense. If we go over to the SolidFire system and we click on Active Volumes, we can see that we do have our volume as we saw before. It's owned by the appropriate account, which would be the same as these two prior ones. And it is not in a volume access group, which makes sense because from CloudStack's point of view, this volume is not attached to any virtual machine. So you would not expect any hosts to have access to this particular volume right now. And that's exactly what we're seeing. We're seeing that only two of our 4 volumes have access by hosts. And that is this one here, root-48, and this one here, vol-1, which makes sense. The SolidFire volume root-48 is being used for the virtual root disk of our VM, and the vol-1 SolidFire volume is being used for our data disk, our virtual data disk for our virtual machine. However, vol-2 is not currently attached to any virtual machine, so we would not expect it to be in an access control list. So all of this looks great. We can take a look at the quality of service. vol-2 actually has the same quality of service as the root disk, which makes sense again. That was where it came from. So everything is looking great here. If we look at the volume details, we can see that if we were to look in the volumes table, the volume under ID 89 is the one that is the virtual disk that is stored on this particular SolidFire volume. And this tells us its virtual size, which again, if we were to look at the volume overview for the SolidFire size of the volume, it's actually going to be triple this. It's going to be the 20 gigabytes plus an additional 40 gigabytes because of that 200% hypervisor snapshot reserve, so we would expect this to be at 60 gigabytes, and in fact it is. So this all looks great. Let's go ahead and attach this new CloudStack volume to our virtual machine. So here I'll just go to the Quick View column. I'll attach the disk. There's our virtual machine. I'll click on the OK button. What's going to happen here is the SolidFire storage plugin is going to be asked by CloudStack to grant access to the 2 Zen server hosts in that one cluster that we have. And so what the SolidFire storage plugin will do is add the iSCSI qualified names of those 2 Zen server hosts into our volume access group and make sure that vol-2 is in that volume access group as well. So now the Zen server hosts will have access to the 3 bottom volumes that we see here in this table. Now let's go ahead and refresh this table and see where we're at. We can see that we do in fact see that vol-2 is in the appropriate volume access group. In this case, it's pretty simple. It's in the same volume access group as the 2 volumes on top of it. And then if we switch over to Zen Center's point of view, we can see here, I'll highlight it, here is our new shared storage repository. It's of the right size, 60 gigabytes, the size of the SolidFire volume. And then within it, if we look at the storage tab, we can see that we have our virtual disk being 20 gigabytes, which is the size of our root disk that we took the volume snapshot of. So that works out perfectly. And it's attached to the appropriate virtual machine. So if we go over to our virtual machine, I'll click on that. We can see here, now since I'm in the console, I'll just do this action first. I'm going to clear this out and then run fdisk-l. We can see here we've got a 20 gigabyte device, that's our root disk. In the middle is our 100 gigabyte data disk. At the very bottom is our second data disk, which is 20 gigabytes, matching the size of the root disk because it's based on the root disk. It was created as a volume snapshot of the root disk. So all of this looks great. Let's switch over to the storage tab. We can see here, just kind of confirming the same information. We have our root disk on one storage repository, in this scenario, therefore being backed by a single SolidFire volume. Our data disk here at 100 gigabytes of virtual disk size on a storage repository that's backed by a different SolidFire volume, and then a third device, or virtual disk in this case, that is on another storage repository backed by a third SolidFire volume. So all three of these virtual disks are on three different SolidFire volumes, each with their own guaranteed quality of service. Okay, great. So we've seen a bunch of different things here. We've seen creating primary storage based on one of the SolidFire plugins, creating compute and disk offerings that make use of that particular primary storage. We've spun up a VM that makes use of that primary storage. We've made a data disk from it. We've used hypervisor snapshots. We've used volume snapshots and created a new CloudStack volume from that snapshot. Now, let's go ahead and make another VM. I'm going to go ahead, I'm on the Instances tab again. I'm going to click on Add Instance. Go through the same process again. Let's click on Next here, making a VM based on a template. I'm going to use the same template, and this is to illustrate how this works from a cloning standpoint on the back end, on the SolidFire cluster. So I'm going to use the same template, click on Next. I only have the one compute offering, but if I picked a different compute offering, what I'm illustrating here is really more based on the fact that it's the same template. It doesn't matter if it's a different or same compute offering. In this case, I just have the one compute offering, so I'll just go ahead and select that one. I will not create another data disk in this scenario, just going to try to keep really focused on what I'm pointing out in this particular instance. So let's just go and click on Next. No affinity requirements, networking is okay, SSH is okay. Let's make the VM's name VM-2, and then I'll click on Launch VM. So what's going on here is we actually are not going to need to go to secondary storage again to make use of that template. That template was already copied down to a SolidFire volume when we made our first VM that made use of that template. So let's switch over to the SolidFire system here. I'm going to click on Refresh. Okay, so we have all of this current information. What's actually happening now behind the scenes is, I'll highlight this particular volume of interest. We are cloning this particular volume into a new SolidFire volume. In fact, if we go over to the Reporting tab and we look at running tasks, I guess it's already done. It was faster than I was expecting for the demonstration here. I'll go back to volumes. We can see here it's actually already done. So the process of cloning this particular volume to make this volume is done. That happened on the back end. We already had a template residing on primary storage in a SolidFire volume. We did a SolidFire clone to create our new SolidFire volume that's going to house our new virtual disk. And if I click on Refresh again, we may be at the point where this is in a volume access group. In fact, it is. So once we created the clone to make our new virtual disk, we went ahead and put the new volume in a volume access group so that our Zen server hosts had access to it. Then CloudStack instructed Zen server to go ahead and provide new unique identifiers for the SR and the VDI within the newly cloned SolidFire volume, so that those identifiers are in fact unique. Once that process is done, our VM can be spun up. Let's go over to Zen Center and see where we're at. So here, we're probably going to be seeing a new shared storage repository kind of appear and disappear. It goes through this process of probing and performing other actions on the data, and then at one point we'll get to where it actually reassigns the unique identifiers. And once that process is done, our virtual machine will make use of that newly created SolidFire volume, which contains a identical version of the SR and VDI in our template SolidFire volume. So it's all a very fast process of cloning a SolidFire volume on the back end, putting that in an access control list, telling Zen Server to reassign the unique identifiers in the newly created SolidFire volume, and then your new virtual machine has immediate access to those contents. So instead of having to go to secondary storage again and copy that data down to an empty SolidFire volume, a lot of this activity is done on the back end, saving front-end I/O and network bandwidth. So it's a very fast and efficient way to spin up new VMs that are based on templates that have been used by previous VMs. And so here we can see our virtual machine. I'll go ahead and click on the brand new one. It is up and running. If I go to the console, we'll see that it's booting up. If I go over to its storage tab, we can see that it just has a single virtual disk. This is its root disk residing on the SR with the name root-49 in it, which is right, I'm going to highlight it right here. We can see that, as you'd expect, it was a 20 gigabyte virtual disk, which I can show in the storage tab. So we can see the virtual disk is 20 gigabytes. But remember, the compute offering said, again, that it had a 200% hypervisor snapshot reserve. So it did, after cloning the SolidFire volume, it made sure the size was appropriate and that the SR, if it needed to, was expanded to take on a larger size. In this case, I used the same exact compute offering, which had the same hypervisor snapshot reserve, of course, as the previous VM. So when I cloned on the back end the SolidFire template, it didn't really have to do a whole lot of work to make things much different. But the end result is here you've got a very fast back-end cloning process, which reduces I/O from Zen Server's point of view substantially, and it reduces a lot of network traffic. So this is a very big improvement over the way VMs are typically deployed through secondary storage, and it kind of depends. I guess you'd have to go into the details on that, but sometimes with secondary storage, if you have virtual machines sharing the same primary storage, then they'll use a linked cloning process on the hypervisor side. But other times they'll target new primary storages and have to copy the template down again. So this can be much faster depending on your particular use case. And it's very space efficient as well, because that SolidFire volume is thinly provisioned from a metadata standpoint, from a data standpoint. All we're doing then is copying the metadata in the background, so it's very space efficient, not to mention fast. And so I think that's just a very interesting and useful feature to have in CloudStack. And again, this is having its own back-end SolidFire volume, which has its own guaranteed quality of service. So whatever this particular VM is doing, it's not going to be impacted by the activities of other virtual machines that are making use of the same SolidFire cluster. You have that performance isolation. So let's go back over to CloudStack, and I'll see here that we have our virtual machine up and running. I'm just going to click on the Instances tab again just to fill in the IP address, so we can see we have different IP addresses as you'd expect. They're both in the same zone. They're both in the running state. So this is all very cool stuff. Let's say that we want to perform a VM migration from one host to another. Let me just take a look, for example, in Zen Center. All right, so I've only got this one VM running on my second Zen server host. Let's say I want to move this one that we just created over to the other Zen server host. All of that kind of functionality works as you'd expect. So let's go over to the quick view column, and we'll say, if I can find it here, where is it? Migrate, migrate to host. There we are. And there's only 2 hosts in this Zen server cluster, so there's only one potential host to migrate it to. It says, as you'd expect, this one is a suitable host to migrate it to. So let's go ahead and hit the OK button, and we can switch over real quick to Zen Center and actually kind of watch this happen. So there it gets briefly quiesced, and it gets moved over to the other Zen server host. We can take a look at its console, and it's blank to begin with. Just hit enter to get that up and running. Let's log in. We've actually not logged into this VM ever. Now we're logged in. I'll go ahead and hit clear fdisk-l. As you'd expect, we have our 20 gigabyte root disk, and that VM migration worked just as expected. So let's go back over to CloudStack. We can see here in the notifications area, migrate was successful. So really, we've covered a lot of different areas here, from adding primary storage, compute offerings, disk offerings, creating brand new instances, adding data disks to them, taking VM snapshots, deleting VM snapshots, taking volume snapshots, creating a new CloudStack volume from that volume snapshot, attaching that to a VM, starting up a brand new instance that makes use of the same template and seeing how efficient that is, and then performing a VM migration from one host to another. So a lot of really cool stuff going on here. One final area I'd like to cover in this particular video is around changing the performance of a particular volume. Okay, let's switch over to the storage tab and take a look at one of our, let's say one of our data disks. Maybe vol-1. I'm going to click on this and scroll down. So we can see we created this one with our disk offering SFDO1, which had 1,000 minimum IOPS and 3,000 maximum IOPS. And to confirm this, let's go ahead and take a look at the SolidFire GUI, volume or vol-1. If I go to quality of service, I'll re-highlight that. Vol-1 has 1,000 minimum IOPS and 3,000 maximum IOPS. And again, in this case, times 1.5 to arrive at the burst IOPS. So let's say we decide that's actually not cutting it for us. We want to give that volume more performance. Easy enough. Let's go back over to CloudStack, and we'll scroll down to the service offerings and switch over to the disk offerings. So right now, myself as an administrator, I have a really simple setup here. I only have a single disk offering. Let's go ahead and make a second disk offering. We'll call this one SFDO2, and maybe we'll say we want 5,000, let's minimum equals 5,000, and maybe maximum equals 10,000. Okay, so this is going to be a more performant disk offering. Shared storage type, again, we don't care about the provisioning type because SolidFire has everything thinly provisioned. For the sake of simplicity here, I'm going to keep the disk size the same at 100 gigabytes, but you could increase that if you wanted to go from 100 gigabytes to 150, 200, whatever. As long as you're going up in size, that's perfectly fine. But again, for the sake of simplicity here, I'm just going to keep that at 100 and focus on the performance characteristics. So if I go to quality of service type and select storage, and then I'll fill in 5,000 for the minimum and 10,000 for the maximum. And then, again, for the sake of simplicity, I'm going to keep the hypervisor snapshot reserve at 200, which is the same as the previous disk offering, and we'll just focus on the change in performance characteristics. We'll go down to storage tags and make sure that we have the right one, SolidFire SAN A. So now we have a very similar disk offering to our original one, with the exception that the performance, the minimum and the maximum IOPS, are higher than our prior disk offering. So let's go ahead and hit the OK button. This will be added to CloudStack's database in a moment. There we are. Now we'll go over to the Storage tab, and under Vol-1, under the Quick View column, and keep in mind this is actually attached. This is a volume that's attached to a running VM. So I didn't have to detach the disk or shut down the VM or anything like that to change the performance characteristics. I'm in the Quick View column. I'll click on Resize Volume. There's our original disk offering. I'm going to select the brand new one, and then I'll hit the OK button. So in a moment, the CloudStack, the SolidFire storage plugin for CloudStack will go ahead and make the appropriate modifications on the SolidFire system. Now, of course, it's going to check to make sure that it can, in fact, increase the performance, that doesn't violate a limitation, things like that. But we do have plenty of performance available. In this particular case, I believe I gave it access to 4.5 million IOPS, so we are only using a small fraction of that. So this operation performed no problem successfully. If we go take a look at this volume, we can see from CloudStack's point of view, it is now associated with a different disk offering, and it has the new performance characteristics. And let's just convince ourselves of this a little bit more thoroughly in this scenario by just going over to the SolidFire system and hitting the refresh button here. So what we expect to see is 5,000 and 10,000, and then really 15,000 for burst IOPS. Let's hit refresh. There we are, 5,000 minimum, 10,000 maximum times 1.5 equaling 15,000 burst. So we've gone ahead and seamlessly, really while the system was using that particular disk, gone ahead and increased the performance of the volume. And this can work in reverse as well. Maybe you have too much performance. You don't want to, if it's a public cloud, maybe the end user decides that's too much performance, he's not using it all, and he wants to go down, basically downgrade to a lower performant disk offering. You can do that as well. So we'll just quickly kind of run through that scenario. Let's go over to the Storage tab again. In Vol-1's Quick View column, we'll go to Resize Volume. We'll pick the one that's actually selected by default, hit the OK button. And in this case, reducing the number of IOPS shouldn't have any quota constraints. You should always be able to reduce the performance. And there we go. It has been resized. If we look at the details of Vol-1 by clicking on its name, and we scroll down a bit, we can see that we're back to our original disk offering with 1,000 minimum and 3,000 maximum IOPS. And again, to confirm this by looking at the SolidFire GUI in this situation, let's go ahead and we'll hit the refresh button, and we should see 1,000, 3,000, and 4,500 respectively. All right, there we are, 1,000, 3,000, 4,500. Very elastic, very seamless. So you're able to upgrade, downgrade performance characteristics. It's a little bit more interesting with changing the size because the hypervisor does have some restrictions about changing the size of a volume that's either attached to a VM or if the VM is running. And that can vary based on your hypervisor type. So that's a little bit more detailed, but changing performance is very simple like this. The hypervisor is not specifically aware of the kind of performance that we are giving that volume on the back end, and it is not going to provide or require any kind of constraints around us changing that. So that all can happen transparently from the hypervisor's point of view. Now, if we bumped up the disk offering's performance characteristics, all of a sudden the hypervisor would see if it was pushing the volume hard enough, it actually had more performance. Or if we took that performance away, it would see performance basically being scaled back. So very, very kind of cool, flexible control from a performance standpoint, all integrated into CloudStack. Okay, so we're approaching the end of this demonstration. Let's go ahead and tear this system down. Basically get back to where we started at the very beginning. So I'm going to go and in the Instances tab, I'm going to go ahead and destroy and expunge both of my virtual machines. Destroy, expunge. Now, as you'd expect, it takes a moment for the system to shut down the virtual machines, and then we have to delete the SolidFire volumes. So this will take a few moments, and I'm going to pause and come back in just a minute. Okay, we're back. So both of our virtual machines have been destroyed and expunged. Let's go take a look at the Storage tab. We can see that we just have our data disks left, and neither is attached to a virtual machine, which makes sense because we don't have any virtual machines left. If I go over to the Snapshots tab, we can recall that we still do have a snapshot. Now let's take a look at this from the SolidFire system's point of view. This is our old data before we deleted and expunged those virtual machines. So what I would expect to happen here is this particular volume, root-49, will be deleted. Root-48, and it's a little tricky here, will not yet be deleted because it has a snapshot. And snapshots in the SolidFire system require the existence of their volume, that they were a snapshot of. So let's go ahead and refresh this. What we will see, though, for root-48 is that it will not be in a volume access group anymore because no one needs access to it anymore. Let's hit refresh. There we are. So root-48, as predicted, is not in a volume access group. Root-49 has been deleted. We can actually see it over in the deleted tab here, so it's kind of in like a recycle bin, but it's not in a volume access group. Let's go back over to active volumes. We can see that we still have our vol-2 and vol-1. Previously, those were in volume access groups. Now, the VMs that they were attached to have been deleted, and from CloudStack's point of view, these are not attached to any VMs at the moment, so they should not be in a volume access group, and as we see in the volume access groups column, they are not, so that all looks great. Now let's go over to CloudStack again, and its Storage tab. So we're on the Snapshots view. I'm just going to click on the Storage tab to quickly return us to the Volumes view. Let's go and delete both of these particular data disks. So we'll go over here and hit Delete Volume, yes, and then Delete Volume, yes. This will just take a moment to actually go and send the commands to the SolidFire system to remove those particular volumes. Then we'll update the CloudStack database. Here we are. If I refresh this just to kind of make sure everything is up to date, we don't have any volumes from CloudStack's point of view. If I switch over to the Snapshots view, we still have a snapshot, which is perfectly what we'd expect. Let's go over to SolidFire's view, and we'll click on refresh in a moment. But let's first take a look and see. We have vol-1 and vol-2. We deleted those. We should expect those to be gone. Now, the only thing we have left is a snapshot from CloudStack's point of view, which is this. I'm going to highlight the one there. So we'd expect this row, this volume containing this snapshot, to continue to exist. Let's hit refresh and see what happens. Perfect. So our vol-1 and vol-2 are in the deleted section. If I click on that, great. Those are, as we'd expect, back in active volumes. We have our SolidFire volume containing our Zen server, actually our CentOS 5.6 64-bit template for Zen server. And we have our one SolidFire volume that is only in existence because it has a snapshot that CloudStack still requires. And in fact, although I won't go ahead and do this, you can take this snapshot as you'd expect and perform operations on it, like creating a template, creating a CloudStack volume from it, just the way that you would with any other CloudStack volume snapshot, and that would work just fine. It does not require the original volume that this particular volume snapshot was created from. At this point, this volume snapshot is essentially on its own, and it can be used the way you'd normally expect to create templates and volumes, and then you can delete it as well, which is what we'll go ahead and do here. So in the quick view column, if I select delete snapshot, and this will just take a moment, I'll hit the yes button. This is going to go ahead and delete the SolidFire snapshot. It's going to realize that the underlying SolidFire volume is no longer in use, and it will go ahead and delete that as well. So if we switch over to the SolidFire GUI, we can see in the old view, we had a volume called root-48 with one snapshot. Now we just deleted its snapshot, and we just realized that we no longer need this SolidFire volume. So if I hit refresh, we should only see the one volume with ID 1372 remains. And there we are, 1372 remains. This is our CentOS 5.6 64-bit template for Zen server. If we were to go ahead and spin up a new VM that made use of this template, we would clone this into a new SolidFire volume and take the path that we saw earlier. But what I'm actually going to do at this point is get rid of my primary storage that we created in the very beginning. And what we'll see here is it actually then goes and does an inventory of the templates that it's created and realizes it needs to clean any of those up. So if I go down to infrastructure, primary storage, and then over to the quick view column of my applicable primary storage, I'm going to enable maintenance mode, which will actually happen very fast here because there's actually no VMs running that are making use of it at present, so nothing needs to be shut down. So now we're in maintenance mode. Go back to the quick view column, and I'll delete primary storage. Hit the OK button. Now this will just take a moment. It's going through and figuring out which templates reside on the SAN still, if any. In our case, there's one. And go ahead and delete those. So we're cleaning up after ourselves. If we go over to the SolidFire system and then hit the refresh button, we should see no more volumes. We're back in a clean state. And if we go over to CloudStack again, we can see that we have what we started with, two local primary storages, the local primary storage of each of my two Zen server hosts. And if I click on service offerings, we still have our compute offering, of course, and our disk offerings. I'll just go ahead and leave those, at least for now. I guess if we wanted to fully clean up, we could delete those right now as well. But if I decided to add a new primary storage based on the SolidFire storage plugin again, I could make use of the same storage tag, and then these would be valid again. So storage tagging and all of that, as you'd expect, behaves the same way for compute offerings and disk offerings with this kind of primary storage. So thank you very much for watching this demonstration. I hope this gives you a good idea of where the SolidFire storage plugin stands in the 4.9 version of CloudStack. Again, this is a demo version at present. This particular release of CloudStack is not GA, but much of this functionality that I've demonstrated here exists in prior versions, although not all of it. So again, thank you for watching, and also feel free to check out some of the other videos I have on SolidFire's integration into CloudStack. There's other videos on both this plugin and what we call the SolidFire shared plugin, which allows you to place multiple virtual disks on the same backend volume. And there's other various plugins for CloudStack and SolidFire as well. Thanks.